from a table of differences for the function is given here and x values are given here, and continue the table to obtain f of 6 and f of 7. See, they are not asking us to find just f of 6 by substitution, x cube minus 5 into 6 minus 7. This is not what they are asking. They are asking us to evaluate these values using the difference table. Okay, so let me do one thing. So instead of going for f of 6 and 7, because table becomes lengthy now, so let me restrict to these values minus 1 0 1 2 3, and let us try to obtain f of 4 and f of 5 using the table. Alright, so now what is the table if you construct here? That is minus 1 0 1 2 3. Okay, and here minus 1, f of minus 1, how much is it? So that is minus 1 minus 5 minus 7, so minus 13. Yeah, so that is 27 plus which is 15 minus 7, so that is going to be 31. So now let us, these are x values and these are y values. Okay, so let us try to write the forward differences, delta y, delta square y and delta cube y. So first forward differences are minus 7 plus 13, that gives you 6, and this is also 6. Wow, and this is also, sorry, this is not 6, and it is going to be 12, and this is going to be 24. Right, so now the second differences which are this is 0, whereas here it is 6 and here it is 12. Okay, and the next difference I can see this is 6 and this is also 6. Now you see something here. Now this remains constant, so the power difference remains constant. All right, so now suppose if we have only the values up to 3, now what we will do is whatever we get here we treat it as a constant and we will move backward. So our aim is to find f of 4 and f of 5. It means if I take 4 and 5 here, how to get back the values from the table. So now let me assume that here the value here is 6, and okay, if it is 6, and what we must have here, we must have 18. Okay, if you have 18 here, and what is it you must have? Tell me. It means here there is something, this something minus 24 must give me 18.
42.
It is enough to add 24 and 18, right? So this gives you 42. And again 35 plus 42 that you need to add. Yeah, so that gives you 77. All right, but what is f of 4 here? F of 4 is nothing but 4 cube plus 5 into 4 minus 7. All right, so that is what, 64 plus 20 minus 7. Did you get the same thing or different?
77 వచ్చింది sir.
Yeah, that is 77 only. So therefore it is correct whatever we have done. Similarly you can get the other guy also. So we will assume this is 6 and this is, so if it is 6, 18 plus 6, that you need to write here 24, and 24 plus 42 you need to write here, that is 66. All right, now you need to write 77 plus 66, that is 143. Okay, so this is how we can extrapolate. We can find the numbers which are after these guys, after the given values. Like we can go for 4, 5 or not. All right, See, they actually gave us these many values because it is easy to identify the all these values. I mean, this is what they're asking us to consider actually, and they're asking us to find f of 6 and f of 7 from the table. Suppose if you have these many values initially, then you know this difference, fourth difference of y is 0. Now it is easy to see that it is a third degree polynomial. Now we don't go for the fifth differences anyway, they are 0 no. So now we will just come back it like this, 0 here and the 6 here and 6 plus 24, that is 30 here, and this is 96 here, and so now 96 plus 143, yeah, so that gives you 239. So therefore I'm saying that f of 6 equal to 239, not by using the function. Try to understand, I did not substituted f of 6 here to compute. Just by using this difference table, we came to know what is f of 6. Okay, so this is how you can find the before terms and the previous, the next terms using this difference table. And also you can find missing terms. But here, to find all of them, we are having some assumptions here. Keep that in mind. Either our difference table will tell us what is the degree of the polynomial. Suppose if it didn't tell you anything, we will assume that the last difference, whatever you get there, that we will treat it as a constant, and we will assume that its degree is, let's say if you are given with 5 values, we'll assume that we have a fourth degree polynomial, or we will try to approximate it with a fourth degree polynomial. Okay, that is what we will do. We are doing it with an assumption. Suppose instead of taking f of x is this one, suppose if I take f of x is equal to some x power 7 plus x cube plus 1. Okay, this third difference you may not find it constant, but if you have only 4 values of it, you can only find only one third difference, one term in the third difference. We will consider that to be the constant term, and we will come back. Okay, so let's see more on these difference operators. Yeah, here you have a problem. So the question is to prove that this relation, if this relation is not here, let me write it again. Forward difference operator applied n times on ux minus n, that equal to ux minus n into ux minus 1 plus n into n plus 1 by 2 into u, this is suffix x minus 2 plus and so on, plus minus 1 to the power of n into ux minus n. Okay, so this is what they're asking us to prove. So here we should understand it this way, like here e acting on ux, you must take it like this. This is ux plus 1, like how we are giving suffix to y, like yi, and similar way we need to treat. Suppose if you have e to the power of minus 1 acting on ux, you must assume that this is same as ux minus 1. Okay, suppose if you have ux minus n, that can be expressed as e power minus n acting on ux, not the average operator, just ux. It is just u, like how we treated y there, and like that only, it is not the average operator. Okay, so now they're asking us to prove that this delta power n ux n minus 1 equal to this expression. Okay, so let us try to do this. So first of all, let us try to observe what is it they are expecting here. So here ux minus 1, ux minus 2 and ux minus n. It means they wanted us to expand this delta in terms of this shifting guy. I mean, I hope we know what is the relation between the delta and the shifting operator. The relation between delta and E, that is this forward difference operator, is identically equal to E minus 1. Okay, now this implies delta power n acting on, delta power n can be identically seen as E minus 1 whole power n. Okay, now this implies delta power n equal to, now we know the binomial expansion. Binomial expansion of this term is nothing but, what is it? So which is e power n minus, yeah. So it's like n choose 0 and n choose 1, you'll get, that is n into e power n minus 1 plus, so what is it, what is the next term we are going to get? That is n choose 2. If it is n choose 2, what is the formula? N into n minus 1 by 2. But here we have the reverse, n into n plus 1 by 2. But anyway, let me see what is happening here. This is e power n minus 2 plus and so on, plus minus 1 to the power of n into e to the power of 0. That's what we can see. Suppose if we act it on u of x, I mean delta power n acting on ux minus n. What is it we can find here? It's like e power n acting on ux minus n. Yeah, minus n into e power n minus 1 acting on u x minus n plus and so on, plus minus 1 to the power of n into e naught acting on u x minus n. So let me see the coefficients actually. So they want ux first. I hope we get ux here, because e power n acting on ux minus n will give me ux only, minus n into this one, e power n minus 1 acting on this will give you ux minus 1 plus n into n minus 1 by 2, and this will give you ux minus 2 plus and so on, plus minus 1 to the power of n into ux minus n. So this is what delta power n of ux minus n. I hope everything is perfect except this plus here. So let me just verify with the problem. Yeah, it's a typo actually. This one is typo. Okay, here it is supposed to be n minus 1, not n plus 1. Okay, it's not n plus 1, this is n minus 1. Alright, so they are asking us to prove this. Yeah, so now the proof is over. Just expand. You know the relation between forward difference operator and shifting operator. Write that relation and you expand it and you operate it on ux minus n. So we got it. So we proved it. Okay. So let us move to the other one. So here there is a problem. Prove the following. Delta power acting on yx equal to yxn plus 1 minus n choose 1 into yx plus n minus 1 plus blah blah blah. So earlier if you observe that we acted it on ux minus n, so that here you have ux plus 1 something like ux minus 1 like that. But here you are acting on yx. The proof is similar. All that you know is delta equal to 1 plus e, or e, is it 1 plus e? E minus 1. Delta is identically equal to e minus 1. Just take power n and take the expansion and substitute the guys, so that you will get. Alright. But the second one, it seems little interesting. u1 plus u2 plus and so on plus un equal to n choose 1 into u1 plus n choose 2 into delta 1 into u1 plus blah 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 plus delta power n minus 1 acting on u1. So everything they'd like to express in terms of uh, u1. Now how to do this? So let's think about b. So what they gave us here is u1 plus u2 plus and so on plus un, and that equal to what is u1. So somehow we would like to get the difference operators here, but in terms of shifting operator we can write it like this: u1 plus this is e acting on u1 plus next one is u3, right? So that is actually u square e square acting on u1 plus and so on plus e power n minus 1 acting on u1. Do you agree with me? So this one, it can be expressed as 1 plus e square plus and so on plus e power n minus 1, this acting on u1. Alright. Now we want to introduce the difference operator here. Now I hope it is enough to prove that. So to prove this expression, it is enough to prove that 1 plus e square plus and so on plus e power n minus 1, that equal to n choose 1 plus n choose 2 into delta plus n choose 3 into delta square plus and so on plus n choose n into delta power n minus 1. So it is enough to prove this relation. Okay, let's see what all we can do here. Okay, so let me do one thing. So this one, let me express it as 1 plus, okay, before that, let me express this equal to 1 minus e power n by 1 minus e. Do you agree with that? This acting on u1. Now this equal to, now let me take, okay, and this equal to, what is it? 1 minus of 1 plus delta. Why? Because we know delta equal to e minus 1. This is what we know. So that implies e equal to 1 plus delta. Yeah, so 1 plus delta whole power n divided by, and e minus 1 is nothing but minus delta. So this is minus delta is acting on u1. Alright. Now this equal to 1 by delta, and what we have here is delta plus 1 whole to the power of n minus 1, this acting on u1. Okay, just I have taken minus common, I have written this expression. Now let us go for the binomial expansion of this. Now this equal to 1 by delta, you leave it as it is. So the binomial expansion of delta plus 1 whole power n minus 1 is nothing but, you know, this, that is n choose 0, delta power 0, you no need to keep, plus n choose 1 into delta plus n choose 2 into delta square plus and so on plus n choose n into delta power n minus 1. Because we have minus 1 at the end, that minus 1 I have written. So this acting on u1, and this equal to 1 by delta into, what is it? Now NC naught is nothing but 1 itself. N choose 0 is 1. So this one and these two terms got cancelled. So this term and this term got cancelled. So after cancellation, we are left with n choose 1 into delta plus n choose 2 into delta square plus and so on plus n choose n into delta power n. This acting on u1. Now we have 1 by delta here, you just multiply with it. So if you multiply, this is n choose 1 plus n choose 2 into delta plus n choose 3 into delta square plus blah 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 plus n choose n into delta power n minus 1. This acting on u1. Now from this we got the result nc1 into u1 plus nc2 into delta of u1 plus nc3 into delta square of u1 plus blah 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 plus this you can treat it as 1 delta power n minus 1 acting on u1. Okay, so just with the known relations we need to move forward. That's it. So all that we used here is the relation between the shifting operator and the forward difference operator. Okay, because initially didn't convince that we will get this form. After walking through right hand side, we came to know, okay, this is fine. All right. So similarly here, you can have some more problems like this. These are problems from the additional problem sheet only. Calculate delta square of x cube. What do you mean by delta square of x cube? Either you can use the direct formulas or you can use the shifting operator also. That is e minus 1 whole square of x cube. Okay, so this is same as e square minus 2e plus 1 of x cube. And what is it? This is e square. It means, now we must be careful. E square, it means you can write x plus 2h whole cube minus 2 into, and this means e acting on x cube will give us x plus h whole cube plus x cube. Okay, so and after simplification, I hope you can see that the answer here is, it is not the third forward difference to write it directly. If it is third forward difference, I am sure it is 6 factorial, but you may have some involvement of h also here. Okay, you just expand it and try to compute. That's it. Okay, and similarly you can think about these guys, delta of x plus 1 into x plus 2. You can take help of shifting operator or directly also you can proceed. Okay, so what is the direct operation? That is delta acting on f of x will give us f of x plus h minus f of h. Okay, and let me show you some solved problems also. Yeah. So evaluate delta square of cos x. So how do you evaluate? Just by using the definition only. You can write what is delta of f of x plus h minus f of x. So you can substitute it in the formula, and maybe using cos a minus cos b, using those formulas we can simplify, and finally you can write the expression.
Sir, in that question, explain last step, sir, once.
What?
Previous problem, last step, sir.
Previous question, it means this one.
Yes, no, sir.
Next one.
No, sir. Soon after, just solved problem, sir. You paste
Oh
in
yeah,
the
solve problem. Huh? Okay.
how sine of x plus h by 2. Last step, sir. Once.
Where? Okay, which one? Which one you want?
Sine of x plus h by 2 to below step, sir. Simplification.
Okay, so let me see. So sine of h by minus 2 sine of h by 2 is there, and this is delta sine of x plus h by 2, right? So if, okay, they didn't apply any difference. Okay, they kept it as it is. Okay, now this one, we have sine theta. Okay, and I want to express it as cos of theta. Then how do you express cos of, suppose if I take cos of pi by 2 plus theta, what is cos of pi by 2 plus theta? That is actually equal to minus sine theta, because pi by 2 plus means you are in the second quadrant. Okay, in the second quadrant, only sine is positive. So for cos, we must have minus. And if it is pi by 2, you'll write the opposite one. So this is the relation. So simply they used it. Why? Because the reason behind using this guy, because we already computed for delta of cos x. So that is what they wanted to make use here. Okay. So if you are actually done with that interpolation formulas, Newton's forward interpolation, backward interpolation, then mostly you may have Newton's forward and backward only. So Gauss is also easy, Gauss central difference formulas. That also you make sure first, and after making sure those guys, yeah, then you come to these differences, finite differences. Okay, don't be panicked by seeing this many problems here. These are all easy, but once if you complete that, then only you come to it. Come here. You can actually see how this problem is done. Delta of f of x by g of x. Actually, what you can do is f of x by g of x itself, you can take it as some new function h of x. Okay, I'm using h for not h, so let me use something else other than h, maybe k. So k of x. Now here, if you want to apply the formula, that is k of x plus h minus k of x. Okay, so accordingly, you need to take LCMs and you need to simplify. All right. So only thing you need to know the definition. If you know the definition, you can do something here. That's it. All right. So this is all about operators, and so you better try to solve these problems also. Problems in the additional problem sheet. If not all, at least you go through at least some. Because from the numerical methods, the maximum expectation is definitely you'll have questions from like bisection, regular policy, neutral absent, and forward interpolation, backward interpolation. 99% these are the topics might be asked. On forward difference and backward difference, you may find it in the objective. Okay, even if it is there in the descriptive, you may find some choice to it. But it's not so difficult topic. It's actually very easy topic to learn. So your wish, like how your mind takes, accordingly you proceed with it. Okay. So with this we are done with the syllabus. Yeah. So we will stop here.